Mrs. Germana Gracia Jacob, ME in Computer Science, lecturer in CPET, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in Computer Science. In today's session, we will be seeing in detail about the array structures in C. So, we will be seeing about the definition of an array, initialization, characteristics, certain predefined streams and the types of arrays. So, what is an array basically? An array is a collection of similar data types in which each element is located in separate memory locations. See, normally we have one variable name for one value. So, using these arrays, if we are going to have say 5 or 6 integer values that is of similar data type, they should either all be integer or all be float or all be characters. They can be placed in continuous memory locations and under the same variable name. Array variables are used to store more than one variable at a time. So, if you say int a, simply that a can have only one value, either 5 or 10 or any digit. Whereas if you declare an array variable int a of 5, then you can store around 5 values in that same variable a. So, this is an example, int a of 5. That means that variable name a can hold at a time 5 values in separate memory locations. So, accessing them also is independent of the other variables. At the same time, using the same variable name without wasting much space, you can hold 5 values. So, what is the use of arrays? As we see the programs, you will be able to understand. So, how are arrays initialized? Initialization is similar to a variable. Assigning some value to it is called initialization. So, while assigning values to array elements, this is one common method of assigning values. Int a of 5 is equal to, I am giving 5 values. So, how is this identified or recognized by the compiler? Always remember that number within brackets represents index or the position of an element in the array. So, always the position of element starts from 0. So, if 5 is the size, it will be from 0 to 4. So, a of 0 represents 1, a of 1 represents the second element, I have entered it as 5, and a of 2 represents the third element, I have entered it as 3. A of 3 represents the fourth element, which is 2, and obviously 4 is 7. So, the order in which I enter the values, this is how the compiler treats it. The position of each element in the array is given by the index of the array. Index is nothing but the number within the brackets. While I am declaring an array, say int a of 5, in that case 5 represents the maximum number of values that an array can hold. Next, we move over to the characteristics of arrays. So, why do we need a data type, a structured data type like this in C? The first thing is, all the elements of an array, they share the same name. So, using this, you don't have, suppose you need around 10 or 20 values to be used in a program, you don't have to find out new names for each of those values. As long as they are of the same data type, you can store them under the same variable name. They are distinguished from one another with the help of the element number. As I mentioned, the number which is present within the bracket is called the element number or the index or the position where the value is stored. So, each value in that particular name can be identified separately. When you give a of 1 or a of 2, it will identify only that particular value which is held at that location. And any particular element of an array can be modified without disturbing the other elements. So, that is another important feature. Though they are stored under the same name and they are stored in continuous separate memory locations, because the address of each value is different and you can easily identify it independently without disturbing the others, any change, updation or modification can be done easily on the elements of the array. You don't have to, it neither takes more time, neither does it involve more computation to identify an array variable. And any element of an array can be assigned to another ordinary variable or to another array of the same type. So, this is just another example of modification. You can identify individual elements, you can change their values, you can assign their values to some other variable, or you can take the values from some other variable and assign it to them. Any change you want, you can do it very easily and separately without disturbing the others. So, that is how we have given here as an example int b is equal to a of 2 and the other kinds. Next we have these array elements which are stored in continuous memory locations. So this is one feature which we have already seen. The location is continuous and they are separate. So accessing them is also faster. And the amount of storage required for holding elements of an array is computed by this formula. It depends upon the data type of the array and the number of variables it holds. So the total bytes in terms of memory allocation is the size of the data type into its array size. So if I say int a of 5, integer short int normally occupies 2 bytes. So the size of the data type is 2 and the size is 5, array size is 5. So 5 into 2, 10 bytes. So this is the total amount of storage required for that array. This is how it is computed. Next we move over to predefined streams. So what are these predefined streams in C? See, predefined streams nothing but already they have an established meaning, they have an established purpose. So they are normally considered as file pointers in C. We all know what is a pointer. It is something that points to the value of a variable. So if you say file pointers, they point to files which contain some valuable information for the execution of a program. This stdin, stdout and stderr are input, output and error files. So all these are actually pointers which point to the file stdio.h. That is why we use this stdio.h header file in each C program, because this file contains all the definitions, meanings and all the other information necessary for the normal execution of a C program. Because every C program we have the standard input from the keyboard, we need the standard display to the monitor, and if there is any error we want it to be done gracefully, we want that error to be indicated gracefully. So for those reasons we need these predefined streams in the program. Their definitions are all present in the header file stdio.h. So these three are simply pointers to that particular file. So now we will see in detail what each of those files hold. This stdin identifies the standard input text. It is associated with the terminal, that is whatever input we give through the keyboard, that is identified as a standard input. So that is whatever we type on the keyboard, it is visible on the screen. So it is a standard input that is given by the user. Next you have the standard output, which is nothing but identifies the standard output text. Normally we see the output on the monitor, so it's associated with the system display. And then we have the standard error files, which is the output stream in the text mode. See, normally when there is an error in your program, you won't have any graphical representation. You just want the computer to tell you that you are having the error. So that is done mostly in the text mode only. You don't spend a lot of time including graphics in that. And this is associated with the standard error stream. So all these are file pointers which point to the stdio.h file. So when that file is included in your program, all these definitions will be understood by the C compiler. So when you give input from the keyboard, it accepts it. When you want the text to display the output on the screen, that also it accepts. And if there is any unknown error, that also is handled in a proper textual mode, indicating that such an error has occurred in your program. So that is the main purpose of these predefined streams. Next we move over to the types of arrays. In types of arrays we have one-dimensional array, two-dimensional array and three or multi-dimensional arrays. So in today's session we will be seeing about the first two types of arrays, the 1D and the 2D arrays. So one-dimensional array. Here the elements of the array are stored in, this is the simplest and the most normal kind of an array. Minimum when you say an array, it should be at least of a single dimension. So they are stored in continuous memory locations. It has only a single dimension, which is nothing but the element number or the index or the position which identifies the location of the element. So this is how it is organized in memory. This is for our understanding. The element is indicated by the array variable name A, and within the square brackets you are having the first position 0, second position 1, third position 2, fourth position 3 and the fifth position 4, and the corresponding addresses. If you see, this is just an example. The address is all incremented by 2 bytes each, 200, 202, 204 and 206. So that means these are all integer variable data types. So they occupy 2 bytes in memory. So the minimum space between two variables is 2. So this is how they are arranged in memory, just for a clearer understanding. So what is the speciality of these 1D arrays? They can contain elements of any data type. It can be integer, float or character or double, and according to the data type the size occupied by that array will be more. And when you say an array consists mainly of characters, it is also referred to as strings. So string is nothing but an array of characters. A continuous location of characters is called a string. There is a difference between the integer and the character strings. An integer array does not have a null character at the end, whereas a character array automatically have the null character indicated by a backslash and O added at the end. So what is the significance of this null character? Why do we say that an integer does not have it and a character array has it? Only when the compiler sees this null character at the end of the array, it will accept or assume or identify that the character array has ended. So every array, when it has a null character at the back, it indicates to the compiler that with this the array is complete. There may be some situations in programs where we declare an array to be of a very large size, say 100 also, but actually we will not be using all the 100 elements in the array. We may be using only 10 or 20, but that we will not know before we use the program. Based on the input that is given by the user, the array may use 10 elements or 50 elements or 25 elements. So to avoid confusion, we simply give a maximum number 100. In such a case, it is waste of time and waste of computation if the compiler is going to go on keep searching till 100. So we want to indicate to the compiler that for this particular input only 10 elements are there. So at the end of 10th element we should give a null character. So that will indicate to the compiler that the array is over with that 10th element. So that is the significance of this null character. This is an example program for 1D arrays. A program to input 5 numbers through the keyboard, compute and display the addition of even numbers and product of odd numbers. So I am entering 5 numbers. In that I may enter even numbers or I may enter odd numbers. The program is supposed to identify what are the even numbers and add them, what are the odd numbers and multiply them. So how using an array I am going to perform this. So again I am having the program start with main and I am declaring integer variables a, m, I and num as an array. A I have initialized to 0, m I have initialized to 1, I is simply an integer variable with no value as such, and num is the name of the array which is also of type integer and its maximum size is 5. So it can hold up to 5 variables of type integer. Next I am using a for loop. So we have seen about loops. So what am I doing in this for loop? Now here I have initialized the value of I. I have declared it here and I am initializing it to 0. I am checking whether it is less than 5 and each time the loop iterates I am implementing its value by 1. I am opening this for loop. So what am I doing in the first step? Printf enter the number I plus 1. So how will it appear to the user on the screen? Printf itself we know it is to display text on the screen. So enter number %d. This is nothing but to display this I plus 1 which is an integer variable. I am using this %d. So the first loop iteration I will be equal to 0. So how will it be printed? Enter number, instead of this %d, 0 plus 1 will be printed. So enter number 1. So here I am giving the value 2. That is done using the scanf statement. To accept any value from the user we have to use the scanf and I am taking ampersand num of I. So in num of 0 the value 2 will be stored. But when it appears to the user it will appear as 1 only because we don't want the user, because the user may be a computer person or not. So if you start from 0, 1, 2, 3, 4 it may not appear very appealing to him. According to him he has to enter 5 values. So 1 to 5 I am going to enter. Just for the sake of the user I am giving that I plus 1, but actually when that value is entered by the user it will be stored only in the location num of 0. So using this for loop, next I am incrementing the value of I plus plus. So now I becomes 2. So here it will be enter number 2 for the user, but it will be stored in num of 1. Then I becomes 3, enter number 3, I becomes 4 and I becomes 5. So it checks whether it is less than 5. So only till 4 it will enter 0, 1, 2, 3, 4. But when it is displayed to the user it will be displayed as 1, 2, 3, 4, 5. So as soon as 5 values are entered, the condition will be false. So it will come out of the loop. So this is how we enter the values in the for loop. We will see after the break how these values are evaluated. Welcome back after the break. So we were seeing the example of an one-dimensional array and how it is executed by a C compiler. So using this particular program, we have accepted numbers using a for loop up till number 5 because the size of the array is 5, and we have stored it in the array of type integer num of I. So now we are going to see, now the values have all been stored. Now we have to see how the compiler is identifying even numbers, summing them up, identifying odd numbers and multiplying them. So this is the first for loop. Now the numbers I have entered are 2, 4, 7, 3 and 8. Now the work of the compiler is to identify which are the odd and even ones. We all know to find out an odd and even number, we normally divide it by 2 using modulo division. If there is a remainder, we take it as an odd number. If the remainder is 0, we take it as an even number. So here we are going to see how this is done. Now I have to do it for each of the 5 elements. That is why I am using a for loop again. Starting from 0 up till 5, I plus plus each time. And now I is 0. We know that the 0th position we have 2, first position we have 1, second position 7, third and then 4th. So these are 5 variables. So first I am checking if num of I modulo 2. During the first iteration, I's value is 0. Num of 0 is 2. Is 2 modulo 2 equal to 0? Yes, 2 divided by 2 is equal to 2 modulo 2 is equal to 0, because 2 divided by 2 quotient is 1, there is no remainder. So it identifies this as an even number. So we are going to sum up the even numbers. For that reason only we had declared one variable a, which is used to hold the sum of the values. So printf even number percentage d num of I. So it prints this num of I as a even number 2, and it adds this num of I to a. A was initially identified as 0. So 0 plus 2. Now the value of a becomes 2. The loop is closed. So the if loop ends over here. Only when this if loop becomes false, we have to go to the else part. So here already the if loop is over. So once again the for loop is executed. So now it becomes I plus plus. I moves from 0 to 1. Num of 1 modulo 2. Num of 1 we have 4. Again 4 modulo 2 will give only 0, because 2 into 2 is 4. So the remainder will be 0. So that is also an even number. So printf even number num of 1. So next it prints 4, and a's value is now 2. So 2 plus 4, a becomes 6, and that is also added here. Again the if loop has been executed. So the for loop will be incremented or updated. So now i's value becomes 2. In 2 we have a odd number 7. So when the if loop is executed, num of 2 is 7. Modulo 2 will give a remainder 1. That means it is not equal to 0. So this if loop will be ignored by the compiler. It will move to the else loop. So in the else loop now we have an odd number. So we have to multiply it. So printf odd number num of I. Num of I is now 2. So it prints the odd number 7. And m's value is initialized to 1. So m is equal to 1 into num of I, which is nothing but 1 into 7. That is assigned to m. Now m's value becomes 7 during this iteration. So the else loop is closed and the for loop is closed again. So we have to get back to this for loop and increment the value of I. Next I will become 3. So num of 3 is 3. So again that is an odd number. So this if loop will be ignored. It will go to the else loop. It will multiply 7 into 3, 21. Again get back to the for loop. Increment the value of I to 4. Num of 4 is 8. 8 modulo 2 is 0. So that is an even number. So it will enter the for loop and it will add it up over here. So along a was 0 plus 2 plus 4. So 6 plus 8, 14. So the value of a will be 14. The if loop is closed. Again increment the value of I to 5. So it will check this condition. 5 is not less than 5. So the for loop becomes false. So automatically control will come out of this for loop. So now m is holding the product of odd numbers and a is holding the sum of even numbers. So that is what is finally printed over here. A prints 14 and m prints 21. So this is how a one-dimensional array is used. So in an array we stored a number of values, how we extracted each value using a for loop, and how we evaluated separately each value and identified their sum or product. So this is a way to use arrays which are one dimensional in nature. So first we had seen about the integer array. This is an example for a character array, an array which holds alphabets. So in this program we are going to accept a string of up to 15 characters, and we are going to display the elements of the string with the element numbers in the separate column. That means if I enter a name, each character of that name should appear in a separate column and its corresponding positions should be identified. So how am I doing this? I am declaring the character array name. Name is the name of the array, which has around 15 is the size, so it can hold up to 15 characters. So I am entering the name using getters of name. Getters, we have seen the function, it is equivalent to get string. So when a character array is equivalent to a string, so you can use this getters function to get the name. And then I am printing printf element number and character. That is, it is just to show the output in a nice fashion. Element number, I have given it as a separate column, I have left some space, and I am printing the character. So this RITA is the name I have given. So each character should be individually extracted and displayed. How does the program do it? Now here if you see again a for loop. Why I am giving this 15 is because that is the maximum size of the array. But actually how many characters have I used? I have given only 4 characters. So that is the reason in a character array, when a null character indicates the end of the array, it is very useful. The compiler will not waste time searching 15 characters. Once that A is over with the name, it will identify the end of the character and it will come out. So here if you see in the for loop starting from 0, if name of I is equal to null, that means it is checking in the first case itself whether the array is holding some value or not. So I have already entered a name Rita, R-I-T-A. So the first position will have the name R. So it will not be a null character. So this loop will be ignored. This exit statement will be ignored. It comes to the statement following the if loop, printf %d and %c. Here I am putting %dy because I am printing an integer value, the element number. And here I am putting %c because I am printing the character that I have entered. That is why %c. So I is 0 because here I is 0, the first time iteration takes place. And the name of I is holding R. R is the first character, so that R is printed over here. Then this for loop closes and I is incremented. So I now becomes 1. Again the compiler checks whether name of I is equal to null. It won't be null because it is having the letter I. So it will ignore this next statement and printf 1 and I. Again this element number is incremented, it will go to the third position which is holding the letter T. So this if will be false, so it will print T and 2. Then again increment I goes to the fourth element which holds A, and the corresponding element number is 3, that will be printed. And again it will increment, it will go to the fifth position now. So here in the fifth position there is no letter which I have entered, it is empty. That means here there will be the null character. So name of I, that is name of 5 is checked with null. Yes, it is null because it does not hold any value. So automatically this exit function will be executed and the compiler will come out of the for loop. If there was any statement here, it would have been executed. Here the program ends, that's all, I have done my work. I have to take the character separately and display the element number which I have done. So here the main function is closed. So this is how the loop gets executed. First the for loop executes. When the for loop proves false, exit statement is encountered. This printf statement is executed each time you have a character to display. So this is how a character array can be used. You can use string functions. Because of the null character, you can declare a maximum size. Even if you don't enter those values, the compiler will know where the character ends and it will terminate the loop. So this is how a character and integer arrays can be used in a one-dimensional manner. Next we move over to two-dimensional arrays. This is similar to a rectangular display of elements with rows and columns. In a 1D array you have only rows. Okay. In two-dimensional array you have the row as well as the column. A two-dimensional array can be considered as a collection of 1D arrays because if you see 3 rows make a 2D array. For the purpose of identifying elements only, we have divided it into columns and rows. As such, if you see, this X is a 2D array which is nothing but 3 1D arrays arranged one on top of the other. So 2D arrays are nothing but a collection of many 1D arrays. So this is how the position is marked. The first element is identified by row 0 and column 0, row 0 and column 1, row 0 and column 2. The second row is identified by number 1, column 0, second row and second column 2 ones, second row and third column are 1 and 2. So this is how you identify the position of elements in a 2D array. So this is the memory map of a 2D array, that is on the system how is the location of elements identified. So actually to make it easier for you I had shown it one below the other, but actually in memory they are organized one behind the other. You have a 0 of 0, 0 of 1, 0 of 2. Then the next row continues after the first row, and after this you will have 2 of 0, 2 of 1, 2 of 2, then 3 of 0, 3 of 1, 3 of 2. So 0, the first square bracket indicates the row, the second square bracket indicates the column. So the values are arranged in this order, and these are the memory addresses. Because I am taking integer as an example, again if you see the values are incremented by 2 each. So 52, 54, 56 and so on. So this is an example program for a 2D array. I am going to initialize single and 2-dimensional arrays, and I am going to perform addition, squaring and cube. So how do I do it? Here I am using both a 1D array as well as a 2D array. So main function, integer type I and j, two variables I have declared, a 2-dimensional array A, maximum size of the rows is 3 and columns is also 3. B is a single dimensional array of the same type integer, that is also 3 in size. So now first I need elements in the array, so I have to enter some values. So printf, enter the numbers, and this is the same procedure that we had seen in the last program. From 0 to 3 I am scanning f b of I. So b of 0, 1, 2, two values 5, 8 and 3 have been displayed. So the values I have entered are 5, 8 and 3. So now what I am going to do is I want to double the numbers, I want to find their square, I want to find their cube. Using a 2D array in just a single for loop I am able to do all the 3 computations. So my first problem is for I is equal to 0, I is less than or equal to 2 and I plus plus. 0, 1 and 2, I am having 3 variables. So I will be having one column for the double, one column for the square and one column for the cube. That is how I have organized it. So a of I comma j, j was initialized to 0 in the beginning itself. So here I is 0 during the first iteration. So this is equivalent to a of 0 comma 0. So a of 0 comma 0 holds b of I into 2. 5 is the first b of 0. I is now 0. So b of 0 is 5. 5 into 2, 10 is stored in a of 0 comma 0. Next step, a of 0 comma j plus 1. J is 0 plus 1 means it is equivalent to 1. So a of 0 comma 1. So in a of 0 comma 1, power of b of I comma 2. b of I is simply 0 only. So that holds the value 5. So power of 5 square. So 5 square is 25, that is stored over here. Then in a of I comma 2, which is nothing but the third column, 5 cube. So 125. This is all done for the first element 5. Then I close the for loop, increment I by 2. Now b of 1. So that is the second element, which is nothing but 8. So the same operation is done again and again. A of 1 comma 1, 1 comma 0. J is nothing but 0. So 1 comma 0 I am doubling 8. 1 comma 1 I am squaring 8. 1 comma 2 I am cubing 8. Then the third element is 3. Again in the second row. I alone is implemented each time. J remains the same. So first it is 0, then 1 and then 2. I am doubling 3, squaring 3, cubing 3. So with this the elements have been arranged. Now I have to display them. So I am printing f square, double, number, double, square and cube. Again up till 3 elements. Printing b of I. So this b of I is printed here, 5, 8 and 3. And then from 0 to 2 I am printing a of I comma j. So this j gets incremented each time. I is incremented over here. So for the first row 3 elements. Then for the second row 3 elements. Then for the third row 3 elements. So this is the outer loop and this is the inner loop. The inner loop gets over first, then only we move to the outer loop. So in the first row all the 3 elements will be entered. In the second row the next 3 elements will be entered. Then the third row the next 3 elements will be entered. So this is how using a 2D array you are able to perform 3 computations with 3 variables using simple for loops. So this is the advantage of a 2D array. finally the for loop is closed, and after the getCH function the main function is also closed. So the questions that could be possibly asked in the session are definition of an array, how to declare and initialize arrays, types of arrays 1, 2 and 3D, predefined streams. We have seen they are file pointers which point to the stdio file which contain their definition. Types are input, output and standard error. Characteristics of arrays are how they have a single variable, how they are stored, how they are modified and how their size is calculated. So this is the final summary of what we have seen. What is an array? What is its purpose? How to give values to the elements in an array? What are the characteristics of the arrays? What are the different types of arrays 1, 2 and 3D? We were able to see only 1 and 2 dimensional arrays in today's session. We will see the 3 dimensional arrays in the next session. The example programs just to indicate the usage of how arrays are used in a program and the predefined streams. So in the next session you will be seeing in detail about the 3D arrays and how these 3 arrays can be used in an efficient manner. Thank you.